Hello everybody, welcome to today's question. In this question we are going to evaluate this integral from the cube root of log 3 to the cube root of log 4 of sine of x squared sine of x cubed, or divided by sine of x cubed plus the sine of log 12 minus x cubed with respect to s. So how do we solve this question, guys? This is very simple. So pay key attention, or you can pause the video and try the question. If you can, then let's dive into the solution. So the first thing I'm going to do here is I'm going to call this integral r. So we say r is equal to the integral, the cube root of log of 3 to the cube root of log of 4, and we call this x squared sine of x cubed dx all over sine of x cubed plus sine of log 12 minus x cubed. Now the next thing I'm going to do is I'm going to make a substitution, guys. I'm going to make a substitution. I will say let x cubed be equal to t. Differentiating both sides, I will have 3x squared to just be dt, and 3x squared dx, and I will have x squared dx to be 1 over 3 dt. So this is my substitution. The next thing here is I have to change the limit of integration from the x word to the t word. So what's gonna be that? It means that if I have x cubed is equal to t, that will mean that the cube root of t is just equal to x. Now remember, guys, when x is equal to the cube root of log 3, that will mean that since x is equal to the cube root of t, comparing this, it means that t will just be log 3 for the lower limit. And similarly, when x is equal to the cube root of log of 4, that will mean that t will be equal to log of 4. So this is the new bound in the t word. So it means that this integral going to be transformed to this. So r will still be equal to the so this is our new integral. Let me get rid of this and reread the question, and we can continue. So this is our question, guys. I have rewritten our question. Now this is r that we simplify, we'll make a substitution, and it has become this integral, which is also r. So what are we going to do next, guys? In this case, I'm going to factor out the 1 over 3, and this 1 over 3 I can multiply by this r still, and it means that we're going to have 3r to just be equal to the integral from log of 3 to log of 4, and now here we just have sine of t dt all over sine of t plus sine of log of 12 minus t. Now, guys, what am I going to do next? I'm going to use a very famous property called the King's property. The King's property states that if we have an integral from a to b of f of x dx, this can be written as the integral from a to b of f of a plus b minus x dx. So this is what we are going to use, guys. So using the King's property, our A is log 3, our B is log 4. So we have 3r to just be equal to the integral from log 3 to log 4 of sine of log 3 plus log 4 minus x. But notice that if you have log A plus log B, this is equal to log of A times B. So log 3 plus log 4 is equal to log 3 times log is equal to log 3 times 4, which is just log 12. So I'm just going to write log 12. So this will be sine of log 12 minus t, all over this will be the same sine log 12 minus t, and for this we're going to have plus sine of log 12 minus log 12 minus t. Are we there, guys? So in this case, we'll distribute this negative and we will have 3r to be equal to the integral from log of 3 to the log of 4. This will remain as sine log 12 minus t, all over this will be sine log 12 minus t plus, and this will be log 12 minus log 12, that will be 0, and this negative times this negative will be positive t. So here we'll just have sine of t, and all with respect to t. Now observe, guys, this green integral is the one we transform to this integral. So what we are going to do now, we are going to add these two integrals together. That is 3r plus 3r. Are we there? So it means that we're going to have 3r plus 3r, and this will be equal to, now observe, we'll keep the limit because they are the same. That means log 3 to log 4. And remember that they both have the same denominator. They are just written in different form, but this is sin t plus log of sin 12 minus t, and this is the same thing. So we maintain the same denominator according to the fraction rule when you're adding like fraction. So this will be sine of log of 12 minus t plus sine of t. Now we add the numerators. When we take common denominator, we add the numerator. So this will be sine of t plus sine of log 12 minus t, and this is our t. Remember that this and this, they are the same, guys, so they just cancel out. So this will be 6r to just be equal to integral from log of 3 to the log of 4 of the t, and this will now be equal to t but evaluated from log 3 to log 4. So if you do the algebra, this will just be log 4 minus log 3, but in logarithm, when we are subtracting, we divide. So it means that our 6r will just be equal to log of 4 all over 3. Now what do we do in solving for r? Divide here by 6 and divide here by 6. So this and this cancels out. So it means that our final answer for this integral is just r is equal to 1 over 6 log of 4 over 3. So this is the final answer for this amazing integral. So if you watched the video up to this point, guys, thank you so much. Please like and share this video. And if you are not yet subscribed or follow, please subscribe to my channel and follow this page for more interesting content in math, physics, and engineering. Once again, I'm Guru Joe, and have a nice day.